Hi everyone, today we're focused on Unit 6, Lesson 3, and this is going to be in Module 4, and we're focused today on Lesson 31. So remember, all of Unit 5 covers the Pythagorean theorem, which just exists in different locations throughout your Eureka modules. So today's lesson is from Module 4, Lesson 31. And we're going to be looking at systems of equations for the Pythagorean theorem. Our first objective says students know that a Pythagorean triple can be obtained by multiplying any known triple by a common whole number. So this is very similar to the concept of dilation that we talked about back in Module 3. Dilation uses a scale factor to make shapes larger or smaller. We can do something similar by using a scale factor to multiply the side lengths and the hypotenuse of a triangle. We can ensure that we will still have a right triangle and that there will be a Pythagorean triple. Our second objective there says students use this method to generate triples. And again, a Pythagorean triple is any three numbers, a, b, and c, that meets the criteria a squared plus b squared equals c squared. An easy to remember Pythagorean triple is 3, 4, 5. We have a leg that has a length 3, a leg that has a length 4, and a hypotenuse of length 5. We can prove really quickly that that is in fact a right triangle because when I use the Pythagorean theorem, 3 squared plus 4 squared equals 5 squared is the same as 9 plus 16 equals 25, and of course 25 equals 25. I can find any new triple by using a scale factor. So if I took that original triple that I know, 3, 4, 5, and multiplied each side length by 2, I get 6, 8, 10. And I can construct that new triangle with a side length of 6, a side length of 8, and a hypotenuse of 10, and just check to see if that is going to also meet the Pythagorean theorem. So 6 squared plus 8 squared equals 10 squared, 36 plus 64 equals 100, and 100 equals 100. So at least in this example, that use of the scale factor did conserve the right triangle as a shape. And this has to do with similar figures, using the scale factor, ratios and proportions. This is all information that we've discussed in Module 3, which was way back in October, November. So if this sounds somewhat familiar, but you're still confused, go back and look in your notes. And using what we know about the Pythagorean theorem and systems of equations, we can use this combination of systems. X plus y equals t over s, and x minus y equals s over t. And when we're given values for s and t, we can write a solution as c over b, comma, a over b. A, b, and c will be a Pythagorean triple. So let's say, for example, they give us a value of s equals 1 and t equals 2. That means x plus y equals 2 over 1, x plus y equals 1 over 2. I can eliminate my y value because I have a positive y and a negative y and combine the rest of my like terms. So I have 2 x's left, and I have 2 over 1 plus 1 over 2, which actually gives me 5 halves total. I divide both sides by 2, and I get x is equal to 5 over 4. Then I plug that value in from one of my equations. So x is 5 over 4 plus y equals 2 over 1. I'm going to create a common denominator on the right-hand side there by multiplying by 4 over 4. Subtract 5/4 from both sides, and I get y equals 3/4. Now my answer is 5/4, comma 3/4. It's a coordinate point. That's a solution to that system of equations. And when I write the Pythagorean triple, A is 3, B is 4, and C is 5.